applying rational functions. Okay? In order to create tunnels, civil engineers devise plans where tunnel boring machines begin drilling at both ends of the tunnel and meet somewhere in between. So this is not anything like real, is it? Yeah, absolutely, isn't it? Okay, this is definitely what they do. It's how they make tunnels. Otherwise, it would take them forever, just one tunnel boring machine trying to dig through a mountain or something. Okay, a tunnel is being built through a section of mountain. One tunnel boring machine alone can finish the tunnel in 4 years. Another machine can finish the job in 3 years. If both machines start at opposite ends and work at the same time, when will the tunnel be finished? What do you think, faster or slower? Is it going to be done faster than 3 or 4 years or slower? Why do you think faster? They're both working together, side by side, so it should take them less time, right? Okay, so what we're dealing with here is a rational problem, okay? And why rational? Because it's a fraction, and variables are in the denominator, okay? So here's the deal. We're going to write this out in words first, and then we'll change to an equation. How about that? Okay? So we have one job that's happening, right? We're making one tunnel, correct? And the first machine can do the job in 4 years. Correct? And we have also the same job. We're both working on one job together, but how long does the second machine work in? 3 years. How long does it take them together? How many jobs are we doing? One job. How long does it take them together? We don't know. Okay? So what does this equation look like without the words? One over 4 plus 1 over 3 equals 1 over x. Excellent. So now this just becomes a simple solving irrational equations problem, right? What's the least common denominator? Very close. 12 is very close. What do you think? 12x, absolutely. Now, are we finding a are we finding a denominator, or are we getting rid of the denominators? Getting rid of them. So let's multiply every term by 12x. What happens in the first fraction when I multiply by 12x? That simplifies with the 12. The 4 simplifies with the 12 and it becomes a 3. So all I have left is 3x. What happens in the second fraction? The 3 simplifies with the 12 to become a 4, and I have 4x. And what happens in the last part? X's simplify equals 12. Wow. This is suddenly like a basic problem, isn't it? What's 3x plus 4x? 7x is correct. And now, divide by 7. What is x equals? Do you remember we had a conversation, especially the last 2 days, where we said sometimes 12 over 7 is perfect, sometimes 1.7 is perfect. It depends on the situation. What does it need to be in this situation? Why does it have to be 1.7 in this situation? 12/7 of a year doesn't really make any sense, does it? Okay? 1.7 years makes sense. Okay? Now, is that our answer? Not exactly, right? Yeah, that does answer the question, but the question was asked to me in a sentence, so I'm going to answer back in a sentence, right? It will take both machines 1.7 years, How about if I spell yours correctly? Will that help? To do the job together. Is that the only sentence I could write? No, there's like 587,004 sentences you could write. Okay? Maybe not exactly that many, but you get the idea, right? Okay? Asks it, we're going to answer in a sentence. Capitalization, punctuation, all that jazz. Okay? Any questions about that? Look at number 2. Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. The speed at which Tobias is driving is 20 kilometers per hour more than the speed at which Alicia is driving. Find the speed at which Tobias is driving and the speed at which Alicia is driving. Okay? This one's a little different. There's no jobs happening, is there? Okay? Here you have to know, first of all, this formula. D equals RT. I hope you already knew that formula. Have you heard that formula before? What's it mean? Excellent. Distance equals rate times time. Very good. Okay? So it says they're driving different speeds in the same amount of time. So the times are going to be equal, so I actually need to solve this equation for time, don't I? Okay? So I'm going to have the distance divided by the rate for this particular formula, and we'll see that in just a second. Let's define some variables first. How fast is Tobias driving? Not how far, how fast. 20 kilometers faster than Alicia. If Tobias is driving 20 kilometers faster than Alicia, how fast is Alicia driving? X. Okay? Alicia's speed is X. So what is, did I spell that right? A-L-I-C. Yeah, I guess. It looks weird. I'm sorry. Tobias. What's Tobias's speed? X plus 20. A 2. Okay, so Tobias drives 300 kilometers in the same time that Alicia drives 200 kilometers. So what can you tell me about their times? They're the same. So if Alicia's time and Tobias's time are the same, could I set up an equation that looks like this? We solved this equation for t earlier and got d over r. So Alicia's time over Tobias's time, is that okay? Okay. So what do we know about Alicia's? We'll say this is Alicia's and this is Tobias's. What do you know about Alicia's distance? Alicia distance is 200. And what's Alicia's rate or speed? X. And that's supposed to equal Tobias's time. What's his distance? And what is his rate? Oh my goodness. How do I solve that? Cross multiply? Okay. So 200 times x plus 20 equals 300 times x. Is that good? Distribute. 200x plus 4,000 equals 300x. Subtract 200x from both sides. 4,000 equals 100x. What's x equal? X equals 40. Now we need to answer the question. Find the speed of Tobias and the speed of Alicia. Alicia is driving. How fast is she driving? 40 Oh, kilometers per hour. And Tobias is driving. How fast is Tobias driving? How do you know that? Oh, because she's driving x and he's driving x plus 20, so he must be driving 60 kilometers per hour. Questions? You have 3, 4, 5, 6, 7, and 8 to do. Okay? How about, oh, that's funny. How about you have 3, 4, and then 1, 2, 3, and 4 to do? You see why I think it's funny now? Okay, good. All right. If you have questions, come see me.